Today is our lab activity, ladies and gentlemen. So if you haven't done so already, open your books to page 199. And on that page, we're doing a lab activity dealing with biodiversity. Biodiversity, our topic of the week. And so before we begin, let's read the problem together. And it says this. Can the loss of one species result in the collapse of an entire ecosystem? Can the loss of one species result in the collapse of an entire ecosystem? So we've talked a little bit about biodiversity this week. You know what an ecosystem is, and you know what species are. Can the removal of one species cause the whole thing to come crumbling down? Take a moment now to write your hypothesis. All right, welcome back. And now here we are ready for this lab activity. And if you notice, I have constructed a device here, which is a giant Kerplunk game. Maybe some of you have played Kerplunk before, one of the smaller versions of Kerplunk. Well, as you know, I like to do things big and bold. So here I've got my jumbo-size Kerplunk game for us to play with here today in the lab to illustrate this activity. So I want to demonstrate some things here for you, okay? First, we're going to be playing this game virtually, and so I will be playing all of the parts. How boring is that? But I will be playing all the parts here today instead of you. But I want to illustrate the analogy that is presented before you. With this Kerplunk game, this entire apparatus, we are going to consider the ecosystem. So remember, an ecosystem is an area that is comprised of the living and non-living, or biotic and abiotic components, and it's all-encompassing. So this whole Kerplunk game is an ecosystem. Now, inside this game, through these holes, I have numerous sticks of different colors. These sticks are all going to represent individual species. And above these species are all of these different colored balls. And these balls represent the stability of an ecosystem. The ability of an ecosystem to stay together is being represented by these balls. And right now, with all of the species intertwined with one another, the ecosystem stability is intact. Now, if any of the stability above is allowed to drop below the biotic component of the ecosystem, that will illustrate instability. So if any of these balls fall down through the ecosystem, that would illustrate instability, and the ecosystem would begin to fall apart, literally and figuratively here with our demonstration. So now, what do the procedures say? Well, step one reads, take turns playing Kerplunk, following the directions of the teacher. So as I mentioned, each of these sticks will represent an individual species, and normally we would take turns, but I'll be taking turns for everybody by removing one species at a time. No matter what that species is, I'm going to remove one stick at a time, representing one species. Next, step two, we'll consider the sticks to be species interacting with other species. And again, each of these sticks represent a species, and currently they are all interacting with one another, creating, if you will, a web of life. It's interconnected food chains here, you might say, that is being illustrated in the center of this Kerplunk game. Step 3, consider the interwoven sticks as a food web. I just mentioned that. Step 4, consider the marbles or the balls to be the stability of an ecosystem due to biodiversity. So what I'm going to be doing is starting to remove one species at a time. And as I do that, I'd like you to consider the questions in the observations section. I'd like you to read them on your own and then respond to them on your own when I am finished playing the game Kerplunk. Now, you will notice I have a number of helpers here. Since I don't have student helpers, I've got my duck brigade here, ready to collect any instability that might arise from my ecosystem. So, are you ready? Here we go. I'm going to remove species number 1. Whatever species that is, it's now out of the ecosystem. And has it affected stability? Well, the obvious answer is, duh, no, it hasn't. In fact, I'm going to keep on removing species, willy-nilly, you might say. I'm removing, one after another. I'm just ripping out these species from the ecosystem. And boy, how many have I removed already? I don't even know. I'm just getting carried away here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've removed 10 species already from this ecosystem, and nothing has happened. There's no instability being represented here. All the balls are intact. So, wow, I guess we could just keep on removing species. What do you think? Yeah, let's do it. All right, let's go to the next type of species here. Oh, hey, another one bites the dust. Now, whether we are driving these species to extinction is not the question. We're just removing them from the ecosystem. Oh, another one gone. We don't even notice any change in stability, do we? We're already up to 13 species removed. Hey, there's another one removed. Then another one bites the dust. 1, 2, 3, 4, 5. We're up to 15 species. We've removed 15 species already, and nothing's happening to our ecosystem stability. Now, does this represent real life? It could. Think about how many species have gone to extinction. And hey, we're still here, right? Yeah. Hey, it looks like the ecosystem is still functioning. And we are losing species at an alarming rate on planet Earth today. But hey, nothing's happening to our stability, right? In fact, even locally, we're losing local and regional species by development in the surrounding areas. But hey, there's no impact yet. So let's keep on moving. There's 16 species. Here's 17 species removing, although on those last two, I don't know if you noticed or not, but there was a little bit of movement in the stability area above these species. I did see some of the stability balls moving a little bit. But hey, no instability coming out the bottom yet. So let's take it up. Oh, the bouncing ball. After removing 18 species, our 18th species resulted in only one instability. No big deal. There's still plenty left here to illustrate the stability of our system. So let's remove some more. 19, 20, 21, 22. Oh! After 22, another one fell. Oh, big whoop-de-doo, right? That's only 2. Nothing to worry about there. But I think I do need to use some more of my helpers here, because I can anticipate something happening here. So let me get some of my duck brigade helpers here, and I'm just going to line some of these up so I don't lose my stability onto the floor. And I know you may not be able to see these, but I am putting many more duckies, rubber duckies, around the catch zone. And I'm going to grab these two balls from the floor, put them in there, because I don't want to be losing. I don't want to lose my marbles. Because I've already lost them long ago. So let's continue, shall we? Hey, I forget what number we're up to. Anybody remember? What were we up to? 20? We'll say 20. So here's 21. If that was 21, I forget. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that was 22. So this was 23. 23. 23. Oh, 24. We lost 3 more stability globes. Let's see. Oh boy. We've only got a few species remaining. Can you see? We've only got a few species remaining. This may be a little bit tricky here. So let's see what happens if I remove this one. Ooh, 2 more have come out. Golly. Okay. I'm going to remove 1 more now. Oh! The removal of 1 last species, as you can tell, has caused the entire collapse of this ecosystem. Stability is no longer existing. All of these globes are representing the instability that resulted from the removal of this species. Now, was it this species alone? Well, no, it was a few species before this one, but it only took 1 more in order for the entire ecosystem to collapse. Now, think about this in terms of real life. Is it possible to remove species from a food web in an ecosystem without anything happening? Sure. But how do we know how many species it will take before the entire system collapses? And remember, you and I, we're a part of this ecosystem as well. So as I leave you with that thought to ponder and some additional time to respond to those questions, I'm going to say bye-bye.